Okay, section 12.6, tessellations, almost done.
Yahoo!
You guys, any of you tell me what a tessellation is?
It's
Not without looking.
It's a
It's
repeating
moving something,
picture.
right?
Repeating what? Picture, sure, what?
That all fits together.
That all fits together. Okay, so it's there. Your book defines it this way: tessellation. Tessellation is a repeating pattern of figures that completely covers a plane. A repeating pattern of figures that completely covers a plane without gaps or overlaps. So the most basic one would be, I'm gonna cheat, squares. I can say here's a square, here's a square, here's a square. It's completely covering the plane of my screen. There are no overlaps. There are no gaps. That's a super basic one, right? You can create tessellations using translations or rotations or reflections. You can find tessellations in art. So your book uses the person that I know of as far as artists that is probably the most well-known artist that uses tessellations is M.C. Escher. So example 1, I'm just going to pull in a picture here.
Cheater.
So I know, isn't it? Good luck drawing this one. So in art, the artist is M.C. Escher. So, I don't know what the title of this one. I don't know if there's a name for this one, but whatever. So there's a repeating pattern in here. I mean, you can kind of see it right away. You're like, well, yeah, I see a guy on a horse, a guy on a horse, a guy on a horse, over and over. But what is the part? So identify the transformation and the repeating figure in this tessellation. So here in mine, it's pretty easy. It's a square repeated over and over and over. But can you find what is actually being repeated over and over? What piece?
The brown horse facing one way and then the white horse facing the other way. Just that piece.
So if you were to just slide it, you could, if you outline, I'm going to pick a color that hopefully you can see, I think red, let's see. No, you can't see red very well on there. Let's pick, I don't know, can you see blue? Yeah, blue will work pretty well. Okay, so if you outline the guy here, right here. So right now I'm outlining the horse, but I'm also at the same time outlining the other guy's hoof that fits in there, if you look at it that way. So there's your horse head, and now I'm outlining the other guy's head in this, right? So this is the part that's tessellating, being repeated over and over and over. But how? What has to be done to do this one? What kind of transformations do you have to use? Can you figure it out? No, take a look at it.
Just slide it.
Just slide? So some of it slid, yeah.
Yeah.
So this guy can slide over here, right? But how do you get it down to, I'll pick a different color. So the one I just did in blue can slide straight over to this horse right here. I'll outline it quickly. This one, sure. But what about the tan one? How do you get from the blue to what I'll outline in green? This one. How do you get to this one from the original blue that I had outlined? Oops, down here.
You flip it.
You have to flip it and what?
Reflect it.
Yeah.
You have to
You have to go
flip it
here
over, right?
and then go
And slide it, right? So it's probably a glide translation,
Yeah.
right? Wasn't that what it was called? Where you flip and slide
Yeah.
the combo, right? So your book also shows another one. There's a couple other ones in here. It's a pretty short section, so I'm not too worried about spending too much. Oops, that was too big. Okay. What's the repeating pattern in this one? The fish type thing. Identify the pattern
Fish and
first.
bird.
So I'm going to see if I can change a color here real quick. Really light. Let's see if you can see really light. Yeah, you can. All right, so how would I outline this? What's the part? Fish and bird. What do you mean fish and
There's no
bird?
bird.
I see a whole bunch of fish.
Yeah, I see the fishes.
Oh, I'm looking at this one on my screen.
Oh.
No different one, really.
The eyes.
So here,
There's a beak.
No, she's looking at a whole other picture.
Yeah.
This one right here.
The one I copied.
the red,
down.
Yeah.
red, blue, and yellow one. So here's my repeating pattern. How does it repeat? What's the transformation?
The tip of
Slides.
the tail right there. And it
The tails all
shoots
go
over.
in a point.
So, right, all these tails meet in a point. So this guy can turn either that way to cover in the, let's change the color ever so slightly. I don't know if it's going to be different or not. To be this one right here, right? So it's turning, it's a rotation one. With that being the center of rotation. And that one can turn over that way, right? So if you recognize, what are you laughing at? Oh, her picture.
Try to draw.
That's a pretty impressive one. I kind of wish I could take a picture and I'll take a picture and add it on
This
at the
one
end just to
is
show.
more impressive.
I will take pictures and add them just to show off your
I'm
skill.
scared to draw.
I see that. Okay, I didn't include the one that's actually an example one in your book. I'll try drawing. I'll see how horrible I am at this. So there's one in your book that looks somewhat like, well, here's the fish mouth. Ooh, that's really big. I don't really want it that big. There's the fish mouth. It kind of goes up and across his forehead and becomes the goose's beak. And then down his neck. And then there's a wing. It goes up, in, up, way down. And there's his tail that goes into the fish's tail. And there. And up. Yeah. Ooh, this is not as easy as it looks in your book. Something like that. So if you were to take that, it should, but it's not going to on mine, match up so that you have, let's see, where's the goose? Along here. Whoop. Let me try that last part again. It was close. Ooh. There's the goose with his eye. And here's the fish with his eye and like gills and whatnot, right? So the whole idea is that if you were to take and cut this and copy it, it should be able to slide into there. If I had done it at all well, the wings would fit into the bottom fin of the fish right there. And you could do it over and over and over. And then same thing with, if I were to, let's see if I can do it again. I don't know if it'll cut that part. I don't want the whole thing. So let's do this and copy it a couple of times. So it should, not that I have, I can't do this. I don't know how to use my own tools. Oh, forget it. Okay, look in your book. But what is the translation that's happened to create the fish-bird combo thing?
It's
Shifted over
It's
and
shifted,
down.
right. So it's
It's
a
like a
glide,
sideways,
right?
yeah.
Yeah. It's a translation, right? So it would slide, whoop, wrong thing. It would just slide down that way, or you could have said it slid down that way, or it slid up that way, whichever, because it's all repeating, right? Hopefully not too
I'm
difficult.
proud of my fishy duck. Pretty good.
So here's an interesting way to determine if a figure will tessellate. Tessellates to say that it repeats over and over, right? So here's example 2.
It's the
Gosh,
first
why
time
is-
adding
That's okay.
numbers.
I know. So this is the first example with numbers, I think, in this. Well, we've done some numbers in this section, chapter, whatever. All right, to determine if a figure will tessellate in a plane. So we can use this formula, and this hopefully looks somewhat familiar. I'm going to write the formula. A equals 180 times n minus 2 all over n. Does that at all look familiar? Oh, it does look familiar. Thanks, Hannah. When did we ever use this?
Well, it wasn't that long ago, but it feels like a long time ago.
This part here, the 180 times n minus 2, what did we use that for?
I know
What was the number?
Gives the total.
Volume.
Nope.
Area.
Nope.
Perimeter. Degrees.
Degrees, thanks. Good, yeah. Gives the total degrees in a polygon. Remember, if you had any number of sides on a polygon, I could just make something up like this. There's 1, 2, 3, 4, 5, 6 sides. And if I were to draw as many triangles as I could from one, I would have 1, 2, 3, 4. There were 6 sides. There were 4 triangles. And then the 4 triangles each gave 180 degrees total, right? So the 4 came from the number of sides, take away 2, right? Times 180. So I'm using that same n to be the number of sides again, because that's going to divide out approximately how many degrees per vertex, per one of these little corners, right? So A is telling you approximately how many degrees there would be on average in any of these angles. It's an average. It's okay. So it says use this formula to determine use the formula for the measure of an angle of a regular polygon. Substitute 8. So if we have an 18-sided figure, does an 18-gon tessellate?
How do you draw an 8?
Yeah, it's nearly a circle to draw it. It's hard to draw. I don't know that I could necessarily draw it without using some kind of a measuring device along with a compass and ruler. Excuse me, and a protractor. So we would substitute 18 for n. So we'd have, I don't need that there. A equals 180 times 18 minus 2 all over 18. So I'd have 180, grab your calculators, times 16 all over 18. But I can simplify easier here. This and this would be 10 and 1. So really I don't need a calculator. It's 10 times 16, which is 160. So is 160 a factor of 360? Because remember 360 degrees around a point, right? Is 160 a factor of 360? In other words, does it go into it evenly? Can you multiply 160 by some whole number and get to 360?
Well,
Hopefully you can say no really quickly.
yeah.
Why can I say no really quickly?
Well, because you're going to start at 200 and there's 60 right there.
So the closest one I know off the top of my head that goes into this just in half would be 180, right?
Mm-hmm.
So 180 80 times 2 would give me 360. 180 and 160 are too close together
Yeah.
for 160 to be able to fit into 360 evenly
Mm-hmm.
when 180 does.
Yeah.
So no, this one will not tessellate. How about something that's 6-sided, a hexagon?
Then you do 180 times 4, which is 720.
And then divide it by
6.
Yep.
Is something.
So you would say 180 times 6 minus 2 all over 6. So if I try to simplify first, I'd have 180 times 4 all over 6. This can be simplified by 3 and 2, and this can be divided by 3 here also. I'd have 60, and I'd have 1. So I would have 120. Does 120 fit into 360 evenly?
Okay.
Yes, it does. It's 3. So a hexagon will tessellate. So if you were to like quickly kind of somewhat accurately sketch a hexagon. I should be able to fit another one. I'll change colors to see it. Here's this. Here. And then another one here. And another one here. So I can cover a plane figure without any overlaps and without any gaps with hexagons. Anybody know off the top of their head what shape are the pieces of soccer balls, traditional soccer balls?
A pentagon. Hexagon. I don't know what shape.
You'd have to look it up then.
I have no clue.
It's a challenge for you. Look it up. Why did it go get big on me? I don't understand that. Okay. So we have a concept in here, a theorem that doesn't have a name, and I'm gonna just bring it. No, I didn't bring it. I'm gonna write it. No, I did. Where is it? I took this picture. Maybe I did. Oh, I did right there. Okay. Here you go. So here is your fun little facts. Every triangle tessellates. Why do you think that is?
Because it's a triangle.
Well, how many degrees are what we just learned here? How many degrees are there in a
Oh,
triangle?
so it's always going to fit in that formula.
Right. There's always going to be 180 degrees in a triangle, right? Always 180 degrees in a triangle. 360 is divisible by 180. It's just 2. So it can tessellate. Sunny, how about a quadrilateral? How many degrees are there in a quadrilateral? 360, right. So 360, hopefully you can clearly see, is divisible by 360. So every quadrilateral will also tessellate. Not necessarily true of everything beyond that. Okay? So identifying identifying symmetry. So one that I just drew, let's see if I can draw it. It's the honeycomb idea, the hexagons. That's why bees can use honeycombs. So let's see here. Hexagon. It would be nice if I had drawn this ahead of time. And no, that's an ugly one. Hold on. Because I want to just tessellate it. Okay, well, we'll pretend that works really well. And I'm going to say, cut it out, copy it to the clipboard, and I'm going to say, copy again. And I can move it to there. And then I can get the next one out, and I can move it to fit in there. And I can create my tessellation. That's not perfect, but it works to see it at least,
Gorgeous.
right? Isn't it gorgeous?
Gorgeous.
Hey,
Bloody gorgeous.
what's that?
You hear me?
No, I did not. Ah, I didn't want that one. I said this one. I know, poor flower. No, not right now. My beautiful red and green flower. So within my nice little honeycomb that I'm creating,
It's a very cute.
isn't it? Hopefully
Why
you're
is it
creating
blue,
one
though?
too. I don't know, because that's what color I made it.
How many sides is it? It's
A
5.
hexagon has 6 sides. Right? Okay, so does it have symmetry? So can I take this and cut it? Do I have line symmetry? Do I have translational symmetry? So if I take a look at maybe this, hey, don't move on me. This one right here. Can I slide it somewhere and have it repeat?
Yep.
Okay, so if I slide it straight across here, I would have it repeat right here, right?
Mm-hmm.
So it has translational symmetry. Slides. No flips. Anything else?
It does everything.
Glide it.
You can glide it, right? So you can glide reflectional symmetry. So if I were to draw a dotted line, let's say down here, I could fold this on top of itself, right? If I just kept the pattern going, and each part would match up to something on the other side. So this part would match up here, right? I could pick any random line on here and find its matching line on the other side,
Mm-hmm.
right? How it's symmetrical. You could show, remember how we looked, I'm not going to pull it back up, but we had, in a hexagon, you had this line of symmetry, and this one, 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 right? So we had several points. So in a tessellation, I could draw any of these as a line of symmetry, right? It will map to itself when you fold it along any of those lines I just did. So if you were to continue any of them, it should map it right. If you continue any of these along here, it should map it to itself.
Mm-hmm.
So there's lots of different types of symmetries within here. So I don't think I took a picture of this one. Darn it. Example 3. Oh gosh. Yeah, right there. List of symmetries in the tessellation. So I'll see if I can, you know what I'm going to do? I'll try and do this quickly. So 0 degrees, 360, good enough.
You're gonna draw it.
What's that?
You're drawing it.
I'm kind of drawing it, yeah. I'll do that. So 0, 1, what? 20. And then 270, I think. Is that right?
For
360 divided by 3.
what? It's like 120.
I know. What's 360 take away 120? 240. Okay, so here. And then if I go and trying to make a nice equilateral triangle is what I'm trying to do. Hopefully this is at least somewhat accurate. Ooh, I think it's not. So I've got this. Yeah, wrong thing. Cut it out. And copy to my clipboard. And then copy it. So let's see if I can figure out where they've got that. There. And then copy it again. And there. Ah, okay. And I forgot to copy it. So good. Here it is. Approximately there. I'm not doing a great job of copying what's in your book, but wrong thing. Copy. Do you see where I'm doing it from?
Yeah.
Mm-hmm.
Okay. So what are the symmetries, if you can kind of imagine what I've tried to copy from your book? I didn't give myself a great... Where are the symmetries? Where would my lines of symmetry be?
Is this it? That shape?
It's tricky.
Is it that shape?
Mm-mm. So yeah, there's some kind of tessellations going on. There are. It's just you'd have to identify what is being tessellated.
Well, this one's going bam, and that one's going upside bam.
Okay, so where would your lines be? There's rotational symmetry, right?
Mm-hmm.
It's sliding up. So like
Sliding.
Centered where? Where's your rotational symmetry?
from the center or
Yeah,
point?
it's not drawn perfectly well, but like if I have a point here, I could rotate around there, right?
Yeah.
And it should line up to itself. So I don't know if it will line up very well because I didn't let's copy it and then see if I can turn it. No, don't shrink it. Turn. I figured this out before. What happened?
You did it with the flower.
I know. There we go.
You should have kept the flower instead of hurting the flower's feelings.
So it should, I mean, it's not perfectly lined up because I did not draw this really well, but you can kind of see where the littler triangle lines up with the littler triangle. The big one kind of lines up with the bigger one.
So it's rotation.
There is rotational, yeah, from every center of every one of the big triangles. But if I were to center it, come on, over one of the little ones too, I have this already turned. It's not perfectly lined up because, like I said, I did not draw it perfectly.
So we have to do this in our homework.
You'll be able to like maybe trace it in your homework. Hopefully, that's kind of my goal, I guess, for
I'm
you.
gonna
My
die.
goal. So that one was, if I leave it there, there was a center. Wrong tool. There was centered there too. So there's rotational symmetry. It's a matter of identifying more than trying to draw it on your own. I'm trying to draw it so you can see what I'm talking about. You need to be able to identify what happened to create the tessellation. So there's a repeating pattern there. You need to be able to identify what is the repeating pattern. Like we did up here. Find the repeating pattern. What is it? Maybe you need to sketch it the best you can.
Look at this best sketch I can. It's beautiful.
Nice. Good job. You need to be able to identify where the lines of symmetry are or where the point of rotation is. So that, I believe, is the last. It is. That's the last example, but I'm going to add on here just for the fun of it, because if any of you are choosing to do your quilt project, this is a way to include tessellations in your quilt. After this example, I'm going to do a quick video too of how to create a tessellation, so stay tuned. Okay, so I'm going to go through the kind of quick directions on how to create a tessellation. This would be if you, for the fun of it, want to do it for art type stuff, or if you want to include it in your quilt. So I have two 3x5 cards right here. It's easiest to start with a square. There are other ways to do this, but this is just an easy way to kind of learn how to do it. I took two note cards, and I'm going to line them up this direction so I don't end up having a fold. You could do this slightly differently. And I'm going to give myself a line so that I have a perfect square, right? And I'm going to cut along this line. I have a couple of these already made. Just do the best you can. Use a paper cutter if you want it perfectly straight, or just try it like this. Do you have tape in here?
I have double side stick tape.
Can you find me some tape real quick? So I have this. So the general idea is that if I were to create some kind of line here and cut it out, slide it over there, and tape it on the side. Cut out a shape here, it doesn't really matter where, slide it down that way, and you're going to create. So I have one already done, right? So similar to the one in your book. So I'm going to cut along these lines, tape it over on the other side. I'm going to do one and the other. So one I have started right at the corner on this one. And I intentionally didn't go to the corner over there so that when I go and slide it, so here's my original piece. I'm gonna slide it across over here. And I don't want to line up that corner because that was the side that I left with a little bit of a tab there. I want to line up this corner so that it's perfectly straight across there. And tape it in place. Right? And then we do the same thing with this one. Cut it out. And this one I did from corner to corner, a little bit easier to line up. So I want to make sure that it's the right direction right now. It's right there, right? So I'm just going to keep it on the table instead of trying to pick it up. Slide it across and tape it on there. Can be kind of fun to create these just for the sake of creating them, for the fun of it. And then I cut off my extra little tape instead of folding it over. So I now have this sheet here where if I go and trace it, I don't have paper here to trace. You reach across, you grab yours. Stealing Lily's notebook. So I have this little guy here. If I were to trace it, I'm going to try and trace quickly for the sake of time, not necessarily accuracy. I've created my template is the thing that I'm tracing. Of that, and then if I slide it, it should fit right over top of the next one to create another tessellation. And you could keep going if you got a big sheet of paper. you could create a nice giant piece like MC Escher. He's got a lot of really cool art. So I've got two that are more or less identical. And I was attempting, see if I can draw it quickly, just attempting to draw something like this, where I've got the center of a flower. It's kind of coming out this way. Like that. And then find a blue where this is the edge of the petal. So this might be the darker side. I'm going to do a quick job. I'm not trying to be super artistic right now. But you can have fun with this. And then lighter shading in here with darker around this. Where this is my center. Right? Maybe my edge is kind of dark. And it fades inward. Maybe you can kind of start to see the flower. I don't have very sharp pencils here right now. Blame it on my kids. And you kind of see that? It's kind of fun to do that. You can also do, if I go back to this, another square really quick. Another way to do a tessellation is to take, I don't know, something like that, and take my scissors back out. This is an interesting one to play with. I'm going corner to corner again for the sake of making it easy to line up. If you don't want to do a slide type one and you want to do like the fish one that was a rotation, I'm going to take this piece and instead of sliding it across to this side, I can stick it on this side so that when I go to trace it, I'm going to have to use my template and turn it so that it would line up there. And then I would have to turn it again and line up there and keep going. Does that kind of make sense? So there's lots of different ways, and you could do it again, but you'd have to be careful with when you're doing it to see what's going to happen with how you would line the other sides up. Which way do you need to turn them so that they will line up? It can be a lot of fun to create tessellations artistically, and or however they can be. It would be very difficult, I think, to sew this if you were to make a true quilt. But for what we're doing for our final project, you could do this on paper. Not so hard. All right, that's it. Thanks for joining us.
Have a nice life.